8.4 is the determinant of a square matrix. The determinant is a scalar. It only applies to a square matrix, and the value of the determinant can be used in different applications, even though we're not going to learn any of them in this section. In the next section, we will learn some of the useful applications for a determinant. Okay, so I'm going to look at this matrix. This is a 2 by 2 matrix, which makes it a square matrix. If you want to find the determinant of a 2 by 2 matrix, I start on the top left and I multiply these together. So AD minus, and then I multiply in the opposite direction, BC. That would give me the determinant of a 2 by 2 matrix. As a fun fact, if the determinant of a matrix is 0, then that system has no solution or infinite solutions. And they're talking about if this were representing the coefficient matrix of a system. Okay, so example 1 is just 2 by 2 matrices. As long as you remember to start in the top left, I multiply this, 10, and then I subtract the product of the opposite diagonal. So 10 minus negative 3, and which means the determinant of this matrix is 13. And just show me the one step. Okay, I'm going to do the same on the next one. Start on the top left. So 5 minus the product of the entries in the opposite direction. No, that's 0. So 5 minus 0 is 5. So 2 by 2 matrix, easy, and it will have some applications in the next section. Okay, before we find the determinant of larger square matrices, I'm going to introduce a couple of vocabulary terms. The first vocabulary term is a minor. The minor IG is the determinant of the matrix after deleting row I and column J. Okay, so I'm going to show you what that means. So I'm given this matrix A, which I forgot to write, but I'll put it on the blank notes in a second. Okay, so if I want to find minor 1, 1, I'm going to find the determinant of the matrix left over after I cross off row 1, column 1. So if I ignore row 1 and column 1, I'm left with this matrix right here, which is a 2 by 2. And just like I did before, I can easily get the determinant by starting on the top left of this leftover matrix. So 2 times 6 is 12 minus, and then in the opposite direction, 1 times 3 is 3. So the minor 1, 1 is 9 because that's the determinant after I cross off row 1 and column J, or row 1, column 1. So I'm going to do the same for minor 1, 2. Okay, minor 1, 2 is when I cross off row 1, column 2. So row 1 is this one. Column 2 is this one. So what am I left with? I'm left with the 3, negative 1 and the 1, 6. So I'm imagining that 3, negative 1, 1, 6 is one matrix. If I start on the left of that leftover matrix, I have 3 times 6 is 18. Negative 1 times 1 is negative 1. So 18 minus negative 1 gives me 19. So minor 1, 2 is 19. And then let's do, what's the last one? Minor 2, 2. Okay, so if I were to cross off row 2 and column 2, I would be left with those 4 corners. So I'm left with 3, 4, negative 1, 6. If I imagine those as a 2 by 2 matrix, if I wanted to find the determinant, I would start in the top left, 3 times 6, and negative 1 times 4. So 18 minus negative 4, which would be 22. And if you want to write out these matrices, you can write out these matrices. Okay, now I'm going to add one more word. It's called cofactor. So the cofactor of I, j is negative 1 to the I plus j times the minor, which would be here. Okay, I'll show you. It's basically just changing the sign of the minor in order to be useful to whatever we're trying to calculate. This is some random size matrix. Okay, the main thing to keep in mind, I'll show you why this is true, but if I start on the top left, the cofactor will be positive. If I go along row 1, it's going to alternate positive, negative, and so on forever. If I go down column 1, It's positive at the top, so it would be minus, plus, minus, and it would keep going like that forever. And it just keeps alternating forever and ever. Because if you know that this is the pattern, it's often easier to follow the pattern than it is to actually find the cofactor of each one. The reason this works, though, is because if I consider the first location, that's row 1, column 1, that would be -1, row 1, column 1. So 1 plus 1 would give me 2. -1 squared makes this a positive entry. If I went to the next place, this is row 1, column 2. So 1 plus 2 would give me 3, which makes this odd. If I keep going right here, this is row 1, column 3. So 1 plus 3 is 4, goes back to even, which is why they keep alternating, because it's just based on the sum of their row and column. Okay, now why do we care about the cofactor? Okay, because the cofactor only changes the sign of the minor. Okay, and that's because to find the determinant of any square matrix, meaning a 3 by 3, a 4 by 4, a 5 by 5, a 10 by 10, I go along any row or column and I multiply the entry by its cofactor. And then I go to the next one, I multiply the entry by the cofactor, and so on and so on. Okay, so we're going to try it for this one, even though you have no idea what that even meant. Okay, so I'm going to find the determinant of A. It is a 3 by 3, which means I can't just use that easy rule I used for a 2 by 2. The symbol for determinant is like absolute value. So the determinant of A is, now I can go along any row or column, even though you had no idea what that meant. Now, why might I pick a certain row or column to go with? If I see a 0, it makes my life a little easier. If I see smaller numbers, it makes my life a little easier. So I'm going to go with row 1 because it has a 0 and because we've never done this before. Okay, now I'm going to kind of set it up. Okay, now I'm going to multiply the entry by the cofactor, and the cofactor is just that sign and that minor. And again, I know you don't know what I'm talking about yet. Okay, so first thing, I'm going to look along this row, and I'm going to consider the signs, the pattern of signs, just like we did like I just showed you. Okay, so on the top left, it starts with positive, which means if I go along this row, this must be a negative, and this must be a positive. Okay, I'm actually going to apply the sign of the cofactor to the term, because it's easier, that's the only way. So I'm going to make that 0 a positive 0, and I'm going to multiply it by the minor in a second. But I need to remind you what a minor is, so I'm going to do that in a second. Okay, 0 times the minor. Okay, the next entry along that row is a 2. It's going to be a minus. I'm going to make it a -2, or the opposite sign of what the entry is. And then I'm going to multiply it by the minor. And then for the last entry, I have a 1. I'm going to make that +1, and I'm going to multiply it by the minor. Okay, now the minor is going to be the one based on that entry that I put. So in this case, the first entry was 0. So I'm going to look at 0. 0 is in row 1, column 1. So if I were to cross off row 1 and column 1, I'm going to look at the remaining matrix, which is this one, and find the determinant of that 2 by 2. So if I start on the top left, -1, -0. Okay, now I'm going to consider the next entry. Because I'm multiplying by the 2, now I'm going to consider the minor when I cross off the column and row that the 2 sits in. Okay, so what am I left with? I'm left with the 3, 4, and the 2, 1. If I start on the top left of the remaining, I have 3 minus 8. Okay, and then the last term I went to was that 1. So if I look at 1, if I were to ignore its row and column, I would be left with this matrix. So I'm going to find the determinant of that, and that'll be the minor. So if I start on top left, that's 0 minus -4. I'm going to put 0 plus 4. Okay, that's the setup, and then I just have to calculate it. Okay, so 0 times -1 is 0, which is why I like zeros. Plus 1 times 4. So 10 plus 4 is 14. So the determinant of matrix A was 14. Okay, now that you've seen it, we're going to try it again. Okay, for example, I'm going to find the determinant of b. And I'm going to do it in a different row or column just so you can see it done in a different way. Okay, since it's a 3 by 3, I want to pick either a row or column to go along. Okay, so I might use this row just because it has the 0 there, and if I multiply by 0, it makes one of the terms go away. Or I might want to use this column because that also has a 0, and I can go on any row or column. I'm going to use, I think I'm going to do the column just to show you what it looks like when you do a column. Okay, so this is the column I'm going to go with. Okay, I'm going to find the determinant b along that column. Before I continue, I'm going to think about the signs that are contributed with the cofactor so I can put them on the entries instead. Okay, so you're if I start on the top left, this would be a positive. So this is positive, this is negative, this is positive. And then they keep alternating. So if I go down, if that's a positive, this is a negative, and this is a positive. Okay, so I'm going to go down. So for the first entry, it's a -2 or positive -2. It's -2. It'll be times the minor. The next one is -0 times the minor, although I don't even care about the minor because it's 0, plus 1 times the minor. Okay, then to find the minor, if I start with the first term was -2. So the minor there is going to be when I cross off the row and column that -2 exists in and find the determinant of the remaining. So this would be 12 plus 5. Okay, now I'm going to do the same thing at 0. I should do the same thing at 0, but really I'm going to do 0 times this. So I don't really have to find the determinant there. I could just say it's going to be zeroed out anyways. But because I want to show you how, I guess I will do it anyways. Okay, so if I go to 0, if I cross off the row and column that 0 exists in, I find the determinant of the remaining matrix, which is the 3, 4, -1, 4. So 12 minus -4, 12 plus 4. And then if I go to entry 1, if I ignore the row and column that entry 1 exists in, and I find the determinant of the remaining matrix, that's 15 minus 12. And thank you for showing your work. Okay, let's calculate this. -2 times 17. This is just 0, which is why I didn't really need to calculate the minor there. Okay, so for the determinant of matrix B, I got -31. And this would have been the same answer if, regardless of which row or column I had gone along, as long as I was really careful with my cofactor and my minors. Okay, there is another method for a 3 by 3 matrix that I will also show you. Sometimes I give you a choice of what method you would like to use. Some people prefer this method. Some people prefer the cofactor method. I'll leave it up to you. So I'm doing the exact same problem as the previous one. So I should get the same answer. Okay. Keep in mind the diagonal method works only with 3 by 3 matrices. So you can't do this with a 4 by 4, and you wouldn't have to do it with a 2 by 2. Okay. So I'm going to set this up before I actually do the calculation. So over here, this is like my scratch work, but you're going to show your scratch work. I'm just rewriting all the entries of the original matrix. Okay, now I'm going to add 2 extra columns. I'm going to repeat the first 2 columns again. So what did I have? I had 3, 3, -1, and 4, 5, 4. This is the first 2 columns. If you choose to do the diagonal method, this is always how you will set it up. Okay, now it's similar to the 2 by 2 in that I always start on the top left. So if I want to find this, the determinant, I'm going to start on the top left. And I'm going to multiply all the numbers as I go along this diagonal. So 3 times 5 times 1 is 15. Plus, okay, now I'm going to go 1 entry to the right. And I'm going to multiply the next diagonal that comes. So now if I go to the 4 and I go down here, 4 times 0 times 1, that's 0. I'm going to add that. And then I'm going to go to the next, starting with the negative 2. Negative 2 times 3 times 4 is negative 24. Okay, I'm going to stop there. The way I remember that I stop is because if I start at the 3 and I try to go down, it's not a full diagonal. So I've already completed everything I need to do. Okay, now I'm going to go do the diagonals in the opposite direction. I'm going to subtract. Okay, and then I'm going to go in the opposite direction. Okay, so I'm going to start on the bottom left. If I multiply these, negative 1 times 5 times negative 2 is positive 10. Plus, I'm going to go to the next diagonal. 4 times 0 times 3, 0. 1 times 3 times 4, 12. Okay, this is how you would show the work, and this should result in the same answer as the cofactor method. What is 15 minus 24? Negative 9 minus 22, which is negative 31. Okay, so if it doesn't specify a method, you're welcome to use the diagonal method. It only works on 3x3s. Because of that, you still need to know the cofactor method in case you're asked to find the determinant of a 4x4.